These are your 12.7 notes on graphing trig functions. So in 12.6b, we learned how to calculate the period and the amplitude of a function based on the graph. By looking at the graph, we could tell those things, or by a description, we could create the graph. So now we're going to take that idea of amplitude and period and figure out how do you determine those values given an equation. So right now I have an equation for sine. Y is equal to A times sine B times theta. And the A value affects the amplitude, so that's pretty easy. Amplitude is your vertical stretch or compression. And so I like to think of it sort of as our slope, the steepness of a line, or how steep or how narrow or wide your parabola was. We've seen A before in other functions. And so I just want to point out that when you have that number out in front, that A value, let's say it was a 2, when you multiply a function by 2 like that, you're actually plugging in an angle, a degree, in for theta, say 30 degrees. And then you're going to take the sine of that 30 degrees, but then multiply the sine value by 2. So if it was 30 degrees, the sine of 30 is a half, and then you double that. And so what's going to happen is your graph is not going to go up to a half, it would go up to 1 for 30 degrees. So it doubled the height. And when we land at 1, we will no longer land at 1, we'd land at 2. So that affects your vertical translations, or vertical stretch. With a B value, I just want you to understand that when you're multiplying the B value, if the B value is 2, you're actually going to multiply the angle by 2 first, then take the sine of it. So again, if we use 30 degrees, we really aren't even going to take the sine of 30, because before we take the sine, your 30 degrees will turn into 60 degrees. And what that creates is a stretch or compression horizontally. And so that affects the period of the function. And the period is not the B value, but it's used. The B value is used in calculating the period. So you take a normal period of a cosine or sine, which is 360 degrees before it repeats, and you divide by that B value. The result is actually an inverse effect. So if that B value is a large number, when you divide 360 by a large number, what happens is the value gets smaller, and so that means I have to have more, it's going to stretch. Hi. So when you divide by B, and B is a big number, it's actually going to compress it because it's going to make more, you got to have more values within that 360. And then the smaller will stretch it. So it actually has an inverse effect where amplitude, larger will get bigger, and smaller numbers will get smaller. Now this other statement here is all about the sign of A. So if A is greater than 0, meaning it's positive, you're going to start at 0, you're going to peak, then you're going to valley. And so those are your 5 points. If A is negative, you're going to start at 0, because you can't flip a 0, but your positives become negative, so you will have a valley first, and then you'll have a peak. So your zeros still remain zeros, but your peaks become valleys, and your valleys become peaks for sine. For cosine, luckily, everything is the same. So the amplitude is the absolute value of A. It has to be positive. So if your A value is negative, you take the absolute value of it. It's a distance. You're telling me how far that graph is from the middle. And the B value, again, is used to calculate the period. 360 divided by B would equal the period. And same idea with the positive and the negatives. If A is positive, then your cosine curve is going to start up. It's going to end up. It'll be down in the middle and hit zeros in between. And so you have a valley. That's a positive cosine is a valley. If you have a negative A value out in front, instead of starting up, we would start down. We would end down, be in the middle up, and then do your zeros. And so what you're looking at there is a peak. I always give those little curls on the ends just because it helps you see that you're starting to do another peak or starting to do another valley in that curve. So it kind of helps round out that curve. So we're going to try a couple of examples. First one, I got the 1/3 out in front of the theta. So that's your B value. It's implied then, if there is no number out in front, that it's a 1. So the amplitude for this graph is 1. And the period for this graph is taking 360 and dividing by 1/3. Well, when you divide by 1/3, which is a really small number, it has an inverse effect. It actually makes the number bigger. So 360 gets 3 times as large. And so 1080 is the period of this function. So this is a sine curve. So I'm going to have to peak and valley within 1080 degrees. So I'm going to draw my line. I'm going to mark 1080 over here. I'm going to use my calculator and figure out where halfway is. That's 540 degrees. Divide by 2 again, and I get a quarter of the way, 270 degrees. To find 3/4, I take 270, add it on to 540, and I get the upper quarter, 810. So even though I broke that into 4 parts, 4 equal parts, we graph 5 points because we start off at the 0. My amplitude is just 1 and -1. So I really need to see those labels. We're going to have our guideline here at 1. Helps guide our graph and with accuracy. And we have a guideline at -1. And so when we go to graph this, it's a sine curve. So it starts at 0, 0. It ends at 1080, 0. And it's in the middle at 540, 0. We peak at 271. And we valley at 810, -1. And then we just connect. I like to go a little bit beyond those points just to show that it continues forever. So it was a stretch. That was a horizontal stretch of the original parent function. Second example, I stuck with the 1/3, changed it to cosine, and now my A value is 1/3. So it's implied that the B value is 1 here. So my amplitude is 1/3, which means this graph is condensed or compressed vertically. We're going to squish it vertically. And then the period is just 360 degrees divided by 1, which is 360 degrees. So the period did not change here. No horizontal dilation, just the vertical. So when I make my scale, I'm going to come all the way to the edge. Call that 360 degrees. In the middle, 180. At my quarter, we got 90. And at my 3rd quarter, we got 270 degrees. I'm going to go up to 1/3 and down to -1/3. Draw my guidelines. And so now this is cosine. So cosine always starts up high, ends up high. So we're up at 1/3. To balance out the 2 highs in the middle, we have to go low. And then you got at the quarters, you're hitting 0. And so this is one great big cosine valley. The number here, the B value, tells you how many total periods you see within that 360. So since the period was 360, I see 1 of them. Next example, I'm going to do both the horizontal and the vertical. So the 2 out in front is our amplitude. A is equal to 2. The period is calculated by taking 360 degrees, dividing by 4, and that's 90 degrees. It's a sine function, and so I still want to see 360 degrees worth of these. So I know we have 90, but if you're less than 360, I still want to see 360 degrees. So I'm going to put 360 here. And 90 is in fourths, so that's fine. I'm just going to label the fourths, 180, 90, and 270. So that's probably the hardest part, is just figuring out how you should break up that axis. My amplitude is 2, so I'm going up to 2 and down to -2. And then I have to actually break up each of these quarters into quarters because the whole peak and valley of the sine is going to happen within 90 degrees. So I break it in half, quarter, 3/4, half, quarter, 3/4, all the way to 360. Draw my guidelines at 2 and at -2. And so now I'm going to start with the first period going to 90. So I'm going to start at 0, 0. I'm going to end at 90, 0. And I'm going to be in the middle of those two, which is 45 and 0. I don't need to see the 45. I'm going up, peaking at 22.5, and valley at the other 22.5. And what I like to do is I like to finish the period before I start the next. Otherwise, I see a lot of dots and I start to see sideways. So now we just continue that fashion. I got a peak and a valley between 90. Now I got to go from 90 to 180. So I start at 90, end at 180, middle in the middle. I peak up and I valley down. There's the second peak and valley. You do it again from 270 in the middle, peak and valley. And then from 270 to 360 in the middle, peak and valley. And there you have it. You should see 4 different peaks and valleys within the 360 degrees. And that's because that B value is 4. They're telling you how many peaks and valleys you'll see within their normal 360 degrees. And the last one, actually for fun, let's make this last one negative. So if this is a -1/2 cosine 3 theta, the amplitude is going to be a half. That's a vertical compression. Notice I didn't say negative, even though it is negative, how I graph this will be different. So it's a cosine, I'll start down. The 3 is used when calculating the period. 360 divided by 3 is 120 degrees. So that's a little different. So I actually, because of the 3, I want to break 360 into 3 equal parts. So here's 360. Instead of dividing it into fourths, I'm going to divide it into thirds. So just kind of eyeball 3 equal sections. So this would be 120 degrees, 240 degrees, and then 360. Within each of those thirds, I got to break those into quarters. So half, half again, half, quarter, 3/4. I'm going up to a half, down to a -1/2. Draw my guidelines. And then we can go ahead, and it's cosine, so usually we start up, but it's a negative cosine, so we're going to start down. At 120, we're going to end down in the middle of those two, which would be 60 degrees. We're going to be up, and at the 30 degrees and the 90 degrees, we'll be at 0. I didn't label those, but that's what they are. There's 1 peak. The 3 for the B value tells me I should have 3 peaks within this negative cosine. So I'm down at 120, I'm down at 240, I'm up in the middle. And then 0 and 0. There's my second peak. And then again, I'm down at 240, I'm down at 360, I'm up in the middle. 0, 0. And there's your 3 peaks of your negative cosine. So for a practice problem, I don't know where my practice problem went. I guess we have a freebie here. Actually, what we'll do is for your practice problem, I have no idea where it went. What I'd like you to do is just analyze, describe. You don't actually have to graph it. So this function, so we'll do y equals 3 sine 1/2 theta. Describe to me the period, the amplitude of that function, and use terms as vertical, horizontal, stretch, or compression. Good luck.